Okay, we have reached the part on forces. So in the first question, we will test you on your ability to actually find resultant force or the net force in a two-dimensional setting. So in a two-dimensional setting, it means that your forces can be slanted. It is no longer limited to vertical and the horizontal direction. So as you can see here, your forces are at an angle, and because of that, you cannot simply add them up. So for example, if you want to find the resultant force or the net force of these 2 Newton and 1.3 Newton forces, it won't be equals to 3.3 because they are simply not in the same direction. They are at an angle. So what you do is that, of course, you can solve it mathematically, but at this point, you have not learned vector summation. So in this case, you have to rely on scale drawing to solve this. Now, because you can see that this vector and this vector are at an angle, you can see that they branch out like that, right? And then after that, it branch out like this. Now, what we know about vector is that for any vector, it consists of two components, the direction, which is in terms of the angle to the horizontal or to the vertical, depending on whichever reference you want to take. And then the other thing about vector is that it has a magnitude. So technically speaking, as long as you keep the direction and the magnitude the same, the vector is the same regardless of its position. So what we are going to do, or what we want to achieve, is that we want to link the vector one after another. So for example, if I take this 1.3 Newton vector, this green one, as the starting, what I want to do in my scale drawing is that I want to take this second vector and I want to shift it to the end. So I want to do something like this, and by doing so, I actually knows that, oh, okay, this is my start point of my vector. This is my start point of my vector, and then this will be my end point. So because now these two vectors are linked up, I can then say that, oh, if I want to use one vector to represent these two vectors, this resultant vector will be represented by this black color vector here. And we usually denote the resultant vector with a double arrow. And the direction, of course, will be from start to end. So the direction of the resultant vector can be expressed as an angle to the horizontal, or it can be expressed as an angle to the vertical, depending on whichever reference is easier for you. Okay, so that is the aim of vector scale drawing. We just want to shift one vector after the other. Okay, so that is the basic idea. So let's see how do we do it properly when it is in an exam setting. So let me erase all this. Now in this question, you are supposed to draw a labeled diagram to show the resultant of this. You are supposed to determine the size and the direction of the resultant force, and this direction should be expressed as an angle to the horizontal. Yeah, so first you need to set up a scale because it is a scale drawing. So for example, a scale could be something as simple as, oh, okay, for every 0.1 Newton, it should be represented by maybe 1 cm. Okay, so that this arrow here, 1.3 Newton, will eventually become 13 cm. So we want a big enough vector diagram, and this 2 Newton would look like 20 cm. But of course, if you look at the space over here, 13 cm and 20 cm is a bit unrealistic. So it will be too big for our space. So what you can do is that you can change this to maybe, instead of 0.1 Newton, you can, every 0.2 Newton, it will be equals to maybe 1 cm. So because of that, then this guy will become about 6.5 cm, and this guy will be 10 cm. I think you can fit that in our diagram here. So let's say I want to use the 1.3 Newton as my starting vector. I want to draw this vector first. And you notice that from the start point, this first factor will make a 40-degree angle from the horizontal. So what you do is that you can start off maybe here, you draw a bearing. So bearing is basically this dotted line, vertical and horizontal. It will assist you in putting your projector. So I can't show my projector on the iPad. So what you need to do is that you need to use your projector, measure that this is 40-degree, and you need to mark it out on your factor diagram. So once you do that, then according to the scale, you are supposed to draw a line that is 6.5 cm long. So you can draw a line that is about 6.5 cm long. So you draw a line that is about 6.5 cm long, and at the end of it, do draw another bearing, because you are going to draw the next vector at the end of the first one. Yeah, so this one, this first vector, label it is your 1.3 Newton vector. So as you can see here, the next vector will be this guy. I will use red. Okay, that is going to the north east, and it makes an angle of 60-degree from the horizontal. So what you do, this is the horizontal, you use your projector, you measure 60-degree up, and then you label it. And then what you do is that you draw 10 cm. So in exam, if you find that your vector is too large and it cut into the question, forget it, just let it cut, it's fine. And then of course remember it's going to the northeast, and then you label this 2 Newton. So this is the end of your second vector. Yeah, okay, so as you can see just now, right, we said that we have, this is the second vector, this is the first one, and I told you that my objective is to move this second vector at the end, right? So we take this and then we move it to the end. Oops, sorry. And then you move it to the end. Oops. Yeah. Wait a second. And then you move this entire thing to the end. Yeah. So now you can see that it kind of looks like it, right? This guy compared to this guy is now similar, right? And you do it in a scale drawing. So that's how you do it. And finally, the step, you want to find the resultant from the start to the end. So a lot of careless mistake is that after you draw the second vector, you immediately goes back. And because you do that, you will end up with a resultant that is looking like that. So try not to do this classic mistake. Label it out first. This is my start, this is my end. So therefore my resultant will be from start all the way to the end. And because this is the resultant, denote it with your double arrow. Then after that, take a ruler, measure this with a ruler, and you will know how long is it. Then use your scale, and then you can work out what is the resultant. As for the direction, you remember in this question they want it to be with respect to the horizontal. You can either measure this side, or you can also measure this side. Of course, this is not a scale drawing for what I'm showing you, because on my iPad I do not have a ruler, I do not have a projector. So I'm just illustrating to you the concept of it. Yeah. Okay, and then for the last part, for the next part, you are supposed to find the weight. So remember, your weight is basically following the equation W equals to mg. But in this case, you do not know the mass because it is not stated in any part of the question. But what you know is that in the context, they tell you that the tension from these two strings is actually supporting the weight of the stone. So if you think about it, these two tensional force, maybe we call it T2 and T1, they are responsible for balancing the weight of the stone, right? The two of them add up should balance the effect of the weight. So it means that this resultant force that you have just found has to be the resultant force of this tension, which is responsible for balancing the downward force, the weight. So actually whatever that you have found here, the resultant force of these two tension has to be of the same magnitude as the weight. So you can find out like that. You do not need to use this equation because you don't even know what is the mass.